All right, analyzing the graph of a function. This is a pretty challenging section because they want us to figure out some things that show up in higher math fairly frequently. The first topic is odd or even functions. Now, when you're looking at them graphically, an even function is symmetrical about the y-axis. So what I want to show you is there's a way to make this decision graphically, and there's also ways to do it using analysis. So our analysis test is f of x equal to f of negative x? And if that is the case, then we call that an even function. So here's what the analysis looks like. We're going to test both of these functions to see if they're even. And the way we do that is we take on one side of our equal sign, we just put f of x the way it's given to us. And we want to know if that's going to be equal to the same function with a negative x plugged in everywhere we have an x. So here's my negative from the function. Here's my negative x. I'm going to square that plus 2. So I'm going to simplify the right-hand side here. And when I square that negative x, I get a positive x. I still have this negative x out front. Sorry, I get a positive x squared. I still have this negative x, negative in front of the x squared, so it stays plus 2. And it looks like these are both the same, exactly the same signs and terms, so it is definitely even. Now, if you think about transformations, negative x squared plus 2, I'm just going to sketch this function because I want you to see it. It's a parabola that's opening down with its vertex at 2. So the whole parabola opens down. There's a reflection because of the negative in front of x squared. And we have this, which is symmetrical about the y-axis. Okay, that's symmetrical. So any quadratic that has its vertex on the y-axis is, by definition, an even function. All right, I'm going to show you one that doesn't work out so great. So again, our test is to take the original function, rewrite it, and see if that's going to be equal to the same idea with a negative x. Now, everything looks fine. My x squared show up just fine, but what happens is that, negative x squared turns into positive x squared, but I wind up with a negative 2x. Okay, so this is not the same as this, so this is not an even function. Okay, on to odd. It's a real similar idea. They're symmetrical about the origin. Probably the easiest even function, or sorry, odd function to see is just plain old x to the third. Okay? It's symmetrical about the origin means that we have basically two separate reflections. If you look at the upper right quadrant of the graph of x to the third, if you flip it over the y-axis and then flip it over the x-axis, you will absolutely get a reflection about the origin. So let's try it with these two functions. Or, yeah, I gave you two separate functions, x to the third plus x, odd function. Actually, I'm going to change this because I have this same function a little bit further down in the notes. So let's just use y equals x to the third. So is x to the third, so our substitution here is a little bit tricky. We're going to put in a negative x everywhere we have an x. So negative x to the third. Is that going to be equal to, we're going to put a negative in front of our whole f of x. Well, when you take negative to the third power, you're still going to get a negative. So this definitely turns into negative x to the third, and that is absolutely equal to negative x to the third. So this is an odd function. On B, we run into a little bit of trouble. So we're going to put in a negative x to the third plus 1 on this side, and then we're going to set the whole function x to the third plus 1 negative. when we do the math on the left-hand side, we definitely get a negative x to the third, but we have this plus 1. On the right-hand side, the negative, when we distribute it, negative x to the third minus 1. So the difference between the plus 1 and the minus 1 means it is not an odd function. All right, I'm going to stop this video. I'll see you on the next one.